Hey guys, I just wanted to walk through the process of doing some of these stress and strain calculations with the data that we've gathered yesterday. This is the data I gathered from just doing one experiment here with the clay and the books and weights used as compression forces. If you were unable for some reason yesterday to get all the data that you needed, you're welcome to use these values for the rest of this activity. Otherwise, use the values that you got yesterday. So we added, successively higher weights, and that compressed our clay more and more depending on how much weight we added to the clay. So the weight should be going up; those should be getting bigger values. The height of the clay should be getting smaller. So the initial height of the clay that I started with was 4.51 inches. And when I added the 2.5 pound weight to that, it compressed to 4.44 inches. So that's kind of how we're reading this. So to fill in the rest of these values in these charts, we need to calculate some different things that are labeled up here. The equations are given to you. Let me just kind of explain these for those of you who are still having trouble with some of these variables and these values. The change of height is going to be referring to the height for my trial compared to my initial height. And so for this first example, the change in height, this delta L, is going to be my starting height, which is 4.51, minus my current height, which is 4.44. We'll always, in this equation, be referring back to the initial height and using the height of whichever trial we're on. Of course, that's something you can punch in your calculator. And of course, for this first trial, it shouldn't be too much of a change in height, just because the first weight shouldn't change the height a whole lot, so I get 0.07. So 0.07 inches is the change in height, and that lets me actually go through and calculate the strain. So my formula for strain is epsilon equals delta L divided by my original height, which is L0. So the change in height that we just calculated was 0.07. The original height that we started with, that's the 4.51. Again, another thing I can plug in my calculator pretty easy. And so that gives me a value of 0.016. So that's the current strain on my piece of clay. So let me write that in real quick. It's going to start out relatively small and should get bigger as we progress. Now, I was pretty careful. I made sure that my cross-sectional area of my clay was 1 square inch. If you ended up doing something with a different cross-sectional area, you have to cross that and use that area calculation in your calculation for stress, because stress depends on how big the cross-section of our material is. And so the equation for stress is sigma equals the force, the weight. In this case, I'm using P for pounds, divided by the area. Well, the force here is 2.5 pounds, divided by 1 square inch, and you don't even need to plug that in your calculator, which is why we suggested using a cross-sectional area of 1. Makes this calculation right here super easy, so that's 2.5. So that's all you need to do to calculate these values. I'm just punching a few things in your calculator. Going on to the next step, for this change in height, I'd still be referring back to my original height. So to figure out the change in height, that'd be like 4.51 minus 4.38. So I'm still going back to my original height to find the total displacement, and that's what I'll use in my strain calculations. So I think that's pretty straightforward. Going on to the next page, once you get those values filled out, we're trying to graph some of these values to create a stress versus strain curve. The graph that we're given here, there's nothing here. You'll have to choose what scale you're going to use for your graph, and you'll have to go back and figure out what the smallest and the largest value is, and that value is going to be, the value that's going to be at the end of your graph. So this first graph's asking for load in pounds versus the displacement. So this first graph's talking about this column, my load in pounds, versus the displacement, the change in height. And so if I'm looking at this, if I want to figure out what values to use on my y-axis, those values need to go from 2.5 to 14.5. So I'm going to put a mark here at the top of my graph, and I'm going to call that, let's call that 14. And then a 14.5 is going to be a little bit above that. Divide that in half, and that's going to give me 7. So I've got going from 0 to 7, 7 to 14. And you can kind of keep successfully dividing this in half as the one way you can develop your scale. So this would be about 3.5. This would be 10.5. That's one way you can think about this. Alternatively, what I did over here, you can increment by 2, 4, 6, 8, 10 up to 14. That's a fine way of doing that as well. And then you have to do the same thing for displacement. Figure out what your smallest and largest displacement is going to be, and that's what you use along the axis down here. So again, this is going to be going from something relatively small to something relatively large. And so I think my biggest displacement is going to be this very last value, which in this case it will be my initial height, 4.51 minus 2.36. So that gives me 2.15. And so my displacement's going to, the biggest thing I really have to worry about is about 2. So if that's 2, halfway in between 0 and 2, that's going to be 1. Halfway in between 1 and 2 is going to be 1.5. Halfway in between 0 and 1 is going to be 0.5. And we could continue to break that down into smaller intervals. So, for example, if I wanted to graph this very first value, the weight here is 2.5. So let's see, halfway through between 3, that's going to be 1.75. So 2.5 is going to be approximately here. It doesn't have to be super precise for this rough graph. So this is going to be about 2.5. Then my change in height is 0.07. Well, that's 0.25. That'd be 0.125. So 0.07 is going to be a little bit smaller than that. So my very first point is going to be something about right there. And so this would be the point 2.5, excuse me. This would be the point 0.07, comma 2.5. Now, you don't have to put that coordinate pair there. That's just what the coordinates of this point are. And so we're going to, continue graphing these coordinate pairs to get an idea what this graph looks like. And so you have to do the same thing for the stress versus strain curve. And that hopefully, if we got some good measurements, if we were careful with how we set things up, we should have a linear part of this graph that we can calculate the slope of, and that'll give us a measure of the elasticity of this material that we're working with. So give that a shot, see what you can come up with, and we'll take a look at that together when I get back.